using an S-list is pretty simple. You want to add or remove stuff, get stuff, whatever. You should use the methods that are provided by the class. However, technically, the way Java syntax works, you can try and do weird stuff. So for example, I can reach directly inside of the object and I could say, hey, you know what, L, I'm not going to use your method. Instead, I'm going to say, take first.next and set it equal to L.first.next. And I can basically do bizarre things to my data structures that are not intended or allowed by the methods provided. You might consider pausing and guessing what's going to happen to this picture. So what happens is this right here ends up pointing back at itself, and we ruin the list. This is not something that an int list or an int list-like object should do. It shouldn't have an infinite loop. I guess this would be the list that's like the number 10 and then an infinite number of 15s, and that's not something we really intended to support with the methods provided. So we could leave a little note somewhere in the file. We could, in comments, do something like, it is incredibly important, right? I don't know, up here. Note, please do not mess with first, right? We could do something like that and hope that other programs will look at it, but other programmers will probably not. And so instead, Java provides us with a feature where instead of declaring a member of a class public, we can instead say private. Okay, so I'll just go in here and I'll say private here, and that does what I want to accomplish. Now the nice thing is, not only is this self-documenting, but it's also enforced by the compiler. If I make this private, and then in another class I do something like L.first.next.next equals L.first.next, when I try and compile that file, I get back that first has private access. So what the private keyword does is it prevents code in other classes from using members, that is variables, methods, or constructors. What private does is it says you cannot use those from outside the slist class. Now if I had a main method down here in slist that did funny things like that, it would work fine because it's part of the slist class. But anybody outside, anybody not editing slist.java could not access first. Now that's not 100% true. There is a funny feature in Java known as reflection, which allows you to bypass these modifiers, but you rarely use it. And what this does is says, if you're a casual programmer, this is something you shouldn't mess with, and the compiler will stop you from doing it. So why do we do that? What's the point of restricting access other than the implicit picture I've presented so far? Well, the basic idea, if we wanted to summarize really the heart of private, is to hide implementation details from the users of your class. The user doesn't need to know that we have a first variable. They shouldn't be messing with it. So by making it private, it's a detail that we, the programmer of slist, need, but the user does not. So that's something that's less for the user to understand. They don't have to know anything about what's going on under the hood. And they could think of the slist class as just a magical black box. They don't have to know about the naked recursive data structure inside. Likewise, you're welcome to change any private method or private constructor or private variable that you want, right? It's your own personal implementation. So if it's marked private, it's not something else someone's going to rely on. So as an analogy, in a car, well, we have some public parts, right? We have the pedals and the steering wheel. We have the idea that there's an accelerator pedal and a brake pedal. One should speed me up, one should slow me down. The steering wheel, when I turn it that way, I should be turning that direction. And then there's a bunch of private details to the car. So you may have a fuel line that is able to carry liquid fuel from one part of the car to the other, but some cars don't have that, right? There is no notion of fuel. You just have a battery and an electric motor. So those are private details you can manipulate however you want because the user does not think about them. They don't think, oh, I need to worry about fuel injection. It's not on their menu. Now, despite the term access control, people use that to refer to the public, private, and so forth feature in Java. It has nothing to do with protection against people trying to do bad stuff with your code, because if they have access to your source code, they could do whatever they want. So that's not what it has to do with. It is instead simply, a way to signal to other programmers, you should not use this, and it's a soft restriction by the compiler, so you can't mess with it. Now there's actually another side point I should mention here, that if you make something public in Java, the expectation is that you will never, ever remove it. In much the same way that if you sit down in a car that has no steering wheel, you're not going to want to drive it. I mean, yes, it is technically possible there'd be some joystick, but that's just not what people expect. So in the case of Java classes, whenever you provide a public method, you're basically announcing to the world that they will have access to that method forever. Okay? So private is stuff you can mess with that the user never needs to know about. Public is something that should stay true forever. Otherwise, we break backwards compatibility with other code. So that's one thing we could do, is make pieces of our class private. So another little augmentation we can do is nesting a class. So if we think about this int node class, I accidentally closed the file, and possibly, yeah, here it is. So here's int node. So it is possible to take this away and say int node really should not be its own class, like file. It should be its own Java file, because that's really a feature of an S-list. So in Java, it's pretty natural that you can just take a class and move it inside of another class declaration. And if I compile this, it'll work just fine. So you can move classes inside of other classes. This will be the boss, and this is now a subordinate class, though in Java the term people use is nested class. Okay. So this is a nested class definition. I made it public, but you can actually also make it private. It is typical, but not always, that what you'll do is put the nested class definitions up top and everything else below, but you can do whatever you want. So typically I'll take this and move it down here, but it just depends on the convention of the environment you're working on. So if you work for a company that always puts the nested classes up front, do that. If you're working for a project team where you always put it at the end, do that instead. Doesn't matter what order. So why? What's good about a nested class? Well, they're useful whenever a class you're declaring doesn't stand on its own. Whenever it's obvious that an int node is really just something used by an S-list and only S-lists, right? It's like it's subordinate to the S-list class in some way. Now, occasionally you will actually want an external program to be able to make instances of int nodes or directly manipulate them in some way. So I could, for example, this would be very strange behavior, but I could do something like public int node get front node, in which case I really need the int node class to be public so that someone is actually able to make int nodes or have references to them. But in a class like this, where the user never needs to even know about int node, we can make this private. So in this way, what this says is that int nodes can never be made by an external user. So if we have S-list user, you could not make an int node. But we're kind of splitting hairs. This is probably getting a little boring for a video. But the basic rule of thumb is if nobody else ever needs an int node reference, make it private. Okay. Now to go one level deeper, and I don't want to get too much into minutia of Java, but if it is the case that the nested class, so I said make this private if no external class uses int nodes, okay? So this is yet another thing like that. If the int node class never uses any detail of the S-list class, if the nested class never needs to look out, you can add the word static here. Now that probably seems like this word static pops up in a lot of strange places. I'm not going to go into right now why they decided to use the word static, but you could imagine this keyword could be never looks outwards, okay? But it's not, it's static. And what that means is that the int node class, like I could not write a method here that uses first. That would not be allowed, okay? So since this int node class, if you look at it, right, it has its own item, its own next constructor, but never does it try and use any of S-list stuff. None of its methods, none of its constructors, none of its variables, so we can make it static. Now what good is that? Well, it gives you a tiny little bit of memory savings for each int node, and you can look in the book for a little more details on that. But the basic idea is simply that a nested class, which is static, cannot access any of the outer classes' stuff. Okay? Now I'm sure that I pushed you to the limit of the amount of syntax that you can fit in your brain without any practice, so don't fret this too much. This is something you'll get a chance to explore a little bit in Project 1. And at the risk of making this lecture even a little more boring and a little more minute, I will make the very minor note that whenever you make a nested class private, these access modifiers no longer really matter, but not an important Java detail. So those are a couple more improvements we could basically make to our S-list class. We can make this class a private static nested class, and we can make the first variable private.